Let's talk about the IoT space and opportunities. There is a huge opportunity here, which I'm sure is not surprise to any of you. Uh, like in terms of 73% of companies are actively investing in IoT, 41% of companies are using data to make informed and timely decisions, and over $100 million is the average increase in enterprise operating income. There has been tons of growth factor for IoT in recent years. This is due to a few key factors around things like developer tools, programming. This device system have become extremely easy to use over the past years. This has greatly helped reduce overall development time. And also the internet is everywhere. This allows connected devices to be put almost anywhere in the planet. And the other factor is Microsoft Azure and other cloud providers have created an ecosystem where it is extremely affordable and easy to build back-end system to power and computing the processing for back-end IoT system. And this all allows from powerful and capable devices to be built that is much smaller and affordable than ever had before. There are challenges in IoT solution like any other solution, from security, privacy, and being able to update those devices on the air. These are fairly significant concern in the context of IoT solution. Uh, and when we talk about huge data, let's just have a glance on the numbers here. As you can see, for a connected car, uh, each day there's like 4 terabyte of data. An oil well, which could be located in a very remote area, push 10 terabyte of data per day. And also the same for weather data, airlines, wind farm, and ships. Uh, and there are some data processing challenge, which is in IoT solution, insufficient bandwidth and intermittent connection, and also perishable data, high latency, security, and no real-time insight, and also delayed actions. Now, with this, what is the solution? The solution is pretty much distributed or decentralized processing of the data. Unlike the cloud-based model where all the data was sent to the cloud, we now have another alternative to select data to the cloud, so that we need processing closer to the data, which is edge computing. So two solutions, one is in the cloud, one is on the edge. With the solution in the cloud, we have remote monitoring and remote management, and also the benefit of merging remote data from multiple IoT devices. And of course, infinite compute and storage to train machine learning and other advanced AI tools. With the edge, we have low latency, pre-process data on-prem, and intelligence at the edge, for example, machine learning, AI, and also as well as offline operation, protocol translation, and data normalization. And last but not least is privacy of data. Now let's talk a little bit about the messaging in IoT solution. There are two different types of messaging in cloud with IoT solution. We have device to cloud messaging, which allows you to send telemetry or messages from IoT device up into the cloud, such as sensor reading temperature. This lets you feed the data into a message queue for processing. We have in the demo I'll present. I'll show you both type of messaging, device to cloud and cloud to device. And cloud to device send control commands or other message from the cloud to the device. Good example is turning on or off a fan or a device and updating a firmware. IoT message communication is enabled through the messaging protocols. There are different protocols here when it comes to IoT solution. The MQTT, Message Queue Telemetry Transport Protocol, is a messaging protocol which is specifically designed for IoT use. It is a lightweight and simple protocol. It supports both publish and subscribe messaging. MQTT was also designed to minimize the bandwidth. There are some other protocols here like AMQP, which is Advanced Messaging Queuing Protocol, is an industry standard message queue protocol. It is used with a message queue, but it can also be used with IoT scenarios. Then there is also protocol like a standard web protocol, HTTP or HTTPS, as well as a messaging protocol like XMPP or other legacy protocol or device-specific messaging protocol. There are some considerations. HTTPS does not have an efficient way to implement server push, and by server push I mean cloud to device. As such, when you are using HTTPS, device pull IoT hub for cloud to device message. This approach is inefficient for both device and IoT hub. Under current HTTPS guidelines, each device should pull for messages every 25 minutes, which is not efficient at all. MQTT and AMQP support server push when receiving cloud to device messages. They enable immediate pushes of message from IoT hub to the device. In the demo, I use the AMQ protocol. If delivery latency is a concern, then MQTT or AMQP are the best protocol to use. And for rarely connected devices, HTTPS works as well. Some consideration around the field gateways. When using MQTT and HTTPS, you cannot connect multiple devices using the same TLS connection. And also for field gateways scenarios, that requires one TLS connection between field gateway and IoT hub for each connection device. These protocols are not really good for this purpose. Low resource devices. The MQTT and HTTPS libraries have a smaller footprint than AMQP libraries. As such, if the device has limited resources, for example, less than 1 megabyte of RAM, this protocol might be the only protocol implementation available for this purpose. Network traversal, the standard AMQP protocol uses port 5671 and AMQTT listen to 8883. Use of these ports could cause problem in networks that are close to non-HTTPS protocol. So then you can use MQTT over WebSockets or AMQP over WebSocket or HTTPS in this scenario. And for payload size, MQTT and AMQP are binary protocols which result in more compact payload than HTTPS. Now let's move on to Microsoft Azure services and what Microsoft Azure has. when it comes looking at IoT, and it allows you to scale to millions of devices connected, sending millions of messages to the cloud. It also allows you to easily integrate with existing systems, as well as offering the ability to analyze and visualize big data. And it also allows built-in security and device management feature to help you manage the overall security of your solution and individual device as well. As you can see, with Microsoft Azure, we have a comprehensive set of Azure services. And if you are to build a solution, there are two paths. The first one and the easiest one is software as a service, which is Azure IoT Central. The second path is platform as a service, and that's where Azure IoT Solution Accelerators comes in play. These are template solution fit to different Azure IoT solution. Remote monitoring, predictive maintenance, connected factory, and device simulation. And of course, you can leverage all of Azure services like Azure IoT Edge, Azure IoT Hub, Stream Analytics for your backend system. Azure IoT Hub is the cloud gateway for IoT solution on Microsoft Azure. It allows establishing bi-directional communication with billions of IoT devices, and it enhances security with per-device authentication, and also provision devices at a scale with DPS, device provisioning service, and manage devices at a scale with device management capability, which we see in a minute in the demo. And also from SDK side, it has a very rich SDK and software development with the support for different languages, C#, Java, and Node and Python. Let's just talk about a little bit on this slide, a little bit more, as it's the heart of any IoT solution. To start from the left side, we have here we have a IP capable device that may connect directly through the IoT hub or through the gateway. Sometimes we might have a low power device that needs to connect to the IoT hub through the gateway. It could be also the protocol translation, because here we have a limited number of protocols, but each device might have its own protocol. And here on the right side, we have the cloud gateway, which is in this case Azure IoT Hub. And when we get the data, we have the option to process real time using Stream Analytics, or we can process the data later, put it on a storage for now, and later process the data. There is two different types of messaging in the cloud with IoT in Azure IoT Hub. So specifically for D2C, we have three types: device to cloud message for time series telemetry. So this is submitting the temperature, humidity, and this type of telemetry. There is another type of communication from the device to the cloud, which is device twins, with the device twins reported properties for reporting device state information, such as available capability, condition, or state of a long-running process. Also, we have file upload for media files and large telemetry badge upload. Sometimes you have you have a lot of data file, you have a gateway, and you want to compress the data, push it to the cloud, and that's where you use the file upload. And also we have cloud to device support in Azure IoT Hub, and there are three ways of cloud to device. The first one is a direct method for communication that requires immediate confirmation of the result. Let's say you have a device and somewhere in the rural area and you want to turn it off or turn it on. That's where you use the direct method. The second method is device twin using the desired property. Let's say you have a firmware and you want to update the firmware version to something else. So that's another way of communicating backend system on the cloud with the device app. And the last one is a cloud to device message for one-way notification. So these are pretty much for just a notification as is a fire and forget model. I leave the pricing to everyone. I provide the link, but in a nutshell, the pricing, there are two tiers. One is a basic tier, the other one is a standard tier. The difference, the big difference between basic tier and the standard tier is the standard tier has the IoT edge support and the cloud to device messaging. And for the sake of time, let me just move to the demo as we have, I guess, 5 minutes more. So for the demo, I have one application that manage the devices. It registered device to Azure IoT Hub, activated device, and also it unregistered device. And also it submitted telemetry to the cloud, and on the cloud we put the telemetry to the service bus, and then we have an Azure function that picks the information and push it to the SQL Azure. And there is another application, it's a device application that we submit some cloud to device using Azure IoT Hub. And with that, let me run my Visual Studio here. So this is a like a backend. It could be a backend solution. As you can see, I have the Azure IoT Hub connection string here, and let me bring the Azure IoT Hub here. And if So as you can see here, I have a resource group with different resources. One is Azure IoT Hub. If I go to the Azure IoT Hub, to the IoT devices, let me refresh. Currently, I have 2 devices. If here I register my device, as you can see, there are 10 devices here in 2 buildings. When we register the device, it creates the device on the Azure IoT Hub. If I refresh here, you see all of the device here. But the status is disabled for these devices. So I need to enable this device. So when I activate the device, technically I can submit telemetry to the cloud. If I refresh on the Azure IoT Hub, you see the status is enabled. Now the second phase for me is to submit the data to the Azure IoT Hub. So if I click connect here, it submits the data to the Azure IoT Hub, and from Azure IoT Hub, I have everything configured to put it on the Azure Service Bus here. So I'm using Azure Service Bus Explorer to show you the data here. Okay, connect to here. So I have this service bus topic, topic name. Let me go to the subscription. I have a subscription here. So if I go to the message and pick the message, let's say the first 10, you see here the device 0, that's the time, and this is the temperature, right? Now let me just disconnect. We have enough data. And also let me show you the SQL server. So this is SQL Azure actually. So I have two queries run here from a table named telemetry. So I have device ID, telemetry, source, and temperature. Currently, there are 360 records, right? Now, I have an Azure function, which is a service bus trigger Azure function, which triggers when there is Azure IoT telemetry on the service bus and inserted to this database. Now, if I go to the Azure portal, here, that's my function app. So I stop Azure function to show you the data on the service bus. Now, if I start the function app and refresh here, messages, we have messages. So if I go to SQL here, now the number is 430. It was 360. So these are the information coming from the service bus. So this is a very simple Azure IoT solution from device up to the backend system, which is in this case SQL Azure. And now here we can build a report, we can consume this data and ship it to wherever way we want. So that was the first demo. The second demo is cloud to device messaging. So for that, I have another application here. So this is a device application. And the idea here is to make a call to the device from the cloud. So if I go to the Azure IoT Hub, so I don't need this application anymore. So let me go to Azure IoT Hub, IoT devices, and this is the device that I'm going to work with. So we have a couple of options here for C2D messaging. The first one is the message to a device is a cloud to device messaging. So let's say if I have cloud, this is so in the message body I have this is a cloud to device message trigger from IoT Hub, and let's say here we have a couple of key pair value 1, add the property key 2, value 2. So this is the message we are going to push to the device app. And as you can see, my device app still is this is my device app. and I have not started the device app yet, right? So if I send the message, it says the message sent, and I don't get any error message, even though the device is offline, right? So when I run the device, let me just run the proper device, close the solution, don't need the solution anymore. So this is the message, and if I run this device app, so as you can see here, this is the message from the IoT, and this is our key pair values, right? So that's one example of cloud to device messaging. So when the device is online, it gets the message, and that's usually we use it for the notification. The second type of cloud to device is direct method. So here, if I call it direct method, let's say if my method name is write to console, and if this is my payload, now if I invoke the method, as you can see, I should be getting an error. Why? Because with the direct method, it's for real-time scenarios, right? So as an example, you want to turn on or turn off a fan. So this is the error that I got, the device is not available. So if I run the device app and bring the device app online, so let me add the method name and the sample payload here. If I make a call, so you see here, this is a direct method call from cloud to device. So this is one example of a direct method. Keep in mind that it could be your back-end system, but for simplicity, I use Azure IoT Hub for submitting cloud to device. It can be a mobile app on your phone. It could be a web interface, anything. Last method for submitting cloud to device is using device twin. Device twin are properties that we have with, it's like a JSON file for Azure IoT solution, and per device, as you can see, we have desired property and reported property. Desired properties are the one that usually we modify on the cloud. For example, the firmware update number, or in this case, I have a interval. And the reported one is the properties here on the desire, but the value from the device itself. So this is another way of communicating cloud to device for desired property, and also a device to cloud for the reported property. Now I have one other device application here. So this is a twin sample. If I set it as a startup, and here we run it.
Sorry to interrupt, Ehsan, we are little 10 minutes over.
Oh, so I'm done in 1 minute then.
Oh, okay.
So as you can see, these are all our desired property here. Interval is 64. And this is 64. Now, if I modify this to 65 and save, I have another method subscribed here to just show it to you here. So as you can see, this is the new value pushed to the device. And also I have the device pushing the latest update time for the desired property. So if I go here, this value is gonna be refreshed. So now it's 4630. So it was changed. So that was another example of cloud to device using device stream, and that's for my demo. And let me bring the slide here. Last slide. So to finalize, I'm going to share some resources. The Internet of Things show is a great resource to keep you up to date with latest and greatest from the Azure IoT team. And also Microsoft IoT School is another great resource. And Microsoft Doc is obviously another great starting point for learning more about the Azure IoT. Thank you so much for your time. If you have any question.
Thank you very much, Ehsan. Really appreciate it. These were really good demos. So I really thank you very much. So there are a couple of questions, but if I can request you to kindly answer those questions just when the second speaker is presenting or getting ready to present. So there are a couple of questions from Hetal and Ashwin. So if you can just directly respond to them in the chat window, that would be greatly appreciated.
Sure, I'll do
Thank
that.
you so
and
much.
Also, I'll drop my email address here as well in the chat window in case someone has other question as well. And
Absolutely.
Thanks for time and opportunity.
Pleasure. Thank you. Okay, thank you, Ehsan. And our next speaker is Mark Bogner, and Mark Bogner is going to be presenting on GraphQL with .NET. Mark, you have the floor.
There you go. Okay. So GraphQL. Interesting enough, I joined the company where I work at almost 2 years now, and one of the interview questions was, do I know anything besides? So they were talking about web services in general, and they asked, what's after REST API? And I didn't know at the time, so I failed the question but got the job. And it was GraphQL. And so GraphQL is basically an API endpoint. It's not an implementation. It's more of like a specification on how it should work. So we're going to kind of quickly walk through it. Just say what's the short-term, long-term future, and then I'll have a short demo. Kind of knowing that we have a small time frame. I know in the initial goal was to present a solution in GraphQL.NET and in Hot Chocolate, but I'm just going to limit it to Hot Chocolate. So, GraphQL is a query language for your API. We're going to talk about how it works. And while I'm going through the theory a little bit, I'm going to present some pros and cons. And then, right, the question is this going to replace REST API? Is it going to replace SOAP? And we're going to explore that a little bit as well. So let's look closer and dive in a little bit into GraphQL. So the history is it was built by Facebook. I think they started 2012. I'm not sure. Don't quote me on the date. And why were they looking at this? Well, they launched their Facebook application on the on mobile, and they had issues, and apparently the customer feedback was very poor, saying that it's slow, it's not working properly. And what happened here, and what we were trying to solve, is basically the under and overfetching. Or with a REST API, as probably everybody's seen a REST API, you first get the user, and then you get the events, and then the friend suggestions and the friends' birthdays, and all of that is an individual calls for the server. Going back and forth, sometimes you get more data than you need, sometimes you get less data what you need. So they were looking for a solution that solves this problem. So they built, oh, wrong one. So this is the schema definition language, basically. What they tried to eliminate here is that over and under fetching, and actually they wanted to limit all those calls to be one call only, and that get the response back. Also, they wanted to make sure that those calls to the server are human readable, like the requests is similar, very close to JSON-like, and it's a typed schema that allows that. So with all the advantages of having a typed schema, the responses are JSON. So again, trying to be more human readable and easily process that information coming from the server. So in general, we have queries. Queries are, the query schema defines of what we can fetch from the server. All of them, you should think about them, and that's why they kind of call it a GraphQL, is like you have a graph that branches out, and they would go like, oh, I have my query schema here, or definition. I want to look for players who are in this team, and I'm looking for the name, team, ID, and the height. Now, all of this information is exactly what I need, and this is what I'm looking for. So when you post that to the server, you're going to get exactly that back. So as you can see here, the result here for the query is basically the players with their name, team ID, and their height. Well, what's interesting here, and you'll see in the presentation as well, is the query itself is a post and not a get. Every call in GraphQL is a post. Just simple information here. Actually, I'm just going back a little bit to the queries here. So this simple example here is just like scratching the surface of how a query could look like. This can be, you could go and have like the property for the players of the team, and then the team would have the location, the name, and then that could have a nested information on the coach, on the ownership, or anything else. So it can become nested. So that's kind of like one of the cons I'd like to bring out, because if you start looking and investigating, reading about GraphQL in general, it's all, very positive, and it's like, wow, it's such a cool tool, but they don't really and actually I took a course to realize that there's some cons to it too, and the nested calls I will add an overhead on the server side, because all of these queries have to be resolved on the server. And if you're going to nest them, you're going to end up limitations. The backend developers will, start banging their head against the wall, trying to figure out how to optimize these queries that are nested. So there are some very useful best practices listed on the GraphQL Learn site, where the schema definition is found, like how you should limit, how you should cache some of the objects. And so that's just one of the cons I wanted to bring up. Now, GraphQL is not just a query. You can also modify the data, right? So these are called mutations. They have a different, the mutation scheme. And as you can see here, you can have parameters, and then in that same post call, you can also get back the, for example, the new player ID, or if you would define the name. So with one round trip to the server, you would add the player, sorry, and you would also get information back on that specific player if you want to. Another portion, right, is so the GraphQL handles queries, right, for fetching data, mutations, to modifying, deleting, all the CRUD operations that are handling in the background. And then we also have subscriptions. The subscriptions are events, right? So anything, if there's something happening on the server side, then you can notify the client. And this typically is implemented with WebSockets. And why I put this familiar question here is basically it's really similar to SignalR, right? Is there a way to quickly notify the client? So some .NET. So this is a very generic, high overview of like what GraphQL does. I think it's, on one hand, it's fascinating that it allows front-end developers to quickly grab whatever they need and based on the schema that's defined. I put in some extra resources here that are very what I went through. So basically the GraphQL Learn is very detailed on how the schema should be built. So, but as just to clarify, right, the GraphQL is not an implementation. So it's not a technology you can download. There are different implementations of it in different languages. And obviously, because we're a .NET user group, I'm going to show one of the .NET implementations. What I found, this EDX course was really, really good. It went through the details on how it works. And I actually forgot, but there's one more, and it was recently posted, I think in May or April, a good presentation on Channel 9. So I'll put that link in here as well. I think it's a couple, if you're interested in GraphQL and want to start learning it, it's a short, I think 4 times 10 minutes video series that it gives some more detail and information on it. Now, back when GraphQL came out, and this is a link to hotchocolate.io. So talk about, right, so some of the .NET implementations. Right when it came out, GraphQL.NET was probably the first .NET implementation for a GraphQL server. It was the only one listed for a long, long time on the GraphQL site, but recently they introduced these other 3. Now, I don't know anything about the middle 2, so Entity GraphQL and .NET GraphQL Query Gen. But when I started investigating GraphQL itself, I found that GraphQL.NET was a little bit behind. I think the main developer kind of dropped off a little bit, and now it's an open source community working on it, but it's not as robust as the hot chocolate implementation, which is I find really useful and really easy to use. So that's kind of like an outline here of like the .NET implementations, and I'll go into the demo. So as I mentioned, we're going to build a very simple GraphQL server. I did some simple implementations and to make it easier, so the demo won't take too long, but I still want to show how easy it is just to create one and how it works. So hot chocolate is the technology we're going to use, and they also have, let me just close this and open up Visual Studio. Okay, so one thing, right? I don't think I mentioned that is I want to focus on the GraphQL server implementation, right, and not how consuming GraphQL endpoint is. So I won't. I'm not going to talk about that now, but I'll talk about the server implementation, which in my opinion, is the fun part. This app you can see here is kind of called Banana Cake Pop. It's the hot chocolate team's GraphQL, which is another I think that one's developed by the GraphQL team. It's just a visual representation and mimics on how a client would work. You can look at the schema, but I'll get back to this in a second. So Hot Chocolate offers this little application for querying your endpoint and looking how the mutations and the query works. So I'm going to create a new project here, and an ASP.NET Core web application, and let's just call it GraphQL meetup. And I'm just going to pick another location here. Actually, I'm going to, there it is. So I'm going to call this meetup. Okay. Perfect. And we're going to go with an empty .NET Core solution or project. Now, once this loads, in the back, just give some additional information here. So there is actually, before I start that part of the implementation, I'm sorry, I'm a little bit unorganized here, but bear with me. I'm going to add 2 existing projects that I built. One is a simple data model so this is built with Entity Framework Core. Very simple. It's a baseball, because I miss baseball in this pandemic, but hope it looks like the season will be back on, hopefully, fingers crossed. So very simple data model here, right? We have a team, we have a league, and we have players that are defined to a team, and then the teams are part of a league. So nothing extra, nothing major. And also we have a position of where they play. Now I also have one more quick solution here, which is basically mock data. I just put this together that will help us generate some information that some data that we can query and use. So this is pretty much like our data. Now this, in the backend, this can be anything. You can, whatever full-blown backend you want. You can even apply a GraphQL endpoint on an existing web server if you want, and you can expose it. Apparently, I've been talking with some developers, and that's one of the practices that's starting to become is like existing REST API endpoints are exposing a GraphQL endpoint, and they run them side by side, and then the front-end developers can easily pick up and work with that. Now, so back to our main web application here. There's 2 packages that we want to install. I'm going to use the visual here instead of the package manager console so you can see it. So we have a Hot Chocolate that we want to install. And we're going to also install the Hot Chocolate ASP.NET Core. So these 2 packages are required to implement a GraphQL server endpoint. Now, once we have these 2, we can start. So very simple configuration, right? We don't need this part at all. Basically, to use GraphQL in here, you just say use GraphQL. That's it. And we're done. That's for initializing it. Basically, we just but we also want to create the query, right, and the mutation. So there's a specific way to do that. So in the services here, we would say services, add GraphQL, and we got a schema builder class, and define a new, we're going to say add query type. Now, what you need to add the query types and have the fetch part of it is you need to have a query class. So that's the first step. Now, I'm going to generate this class. Sure. Okay. Now looking at this query. So very, very, very high level, very simple. If we immediately want to see, I almost forgot. I'm glad I looked at my notes here. There's one more thing we need. We need the data, right? So what we're going to do is I'm going to call the generate data reference, and we're going to call the generate. So all this does is it throws my mock data into a memory database, in-memory database, so we can play around with it while the application is running. Okay, so we also need a reference to basically the data, but we'll call that in a second. So let's say I want a list of my players, and I'll call it players. Okay. So at this point, this is all, I don't know how many lines of code. We already have an endpoint, and we can expose these players as a property. So if I hit my start here, we're going to serve it up, right? And Obi, how are we doing with time? Are we good? Still have a couple minutes?
I think so, yeah. Yeah.
Okay.
So you can take 4 minutes.
Okay. I'll try to keep it very simple then. So so this is the endpoint, and I'm going to say, so the way a post works is you have to define the, oh, why is this a read-only editor? Give me a second. Query. Let's see. Okay. What's going on here? Huh, oh, weird message. All right, I'll just go with an existing one here. So I have this query, but I'm gonna change the endpoint to, yeah. And, oh, I realize what the problem is, my bad. I was typing in the wrong wrong one. So this is basically how you would define the body, and you say you want the players, and once you hit the endpoint here, and oh, sorry, you want to retrieve something back from the players, right? So let's say I want all the players I have in the database, and the name is null. Of course it's null, because you have to actually give back the players. So I did forget to do that. So let's just very quickly create a new baseball context here and return the DB players. Okay, stop, sorry, and make it a list. Perfect. And we don't need a setter. Okay. So we deployed it again. At this point, if I execute, then by magic, we already have all the players listed here. Now you can say, I want more information. I want to know their height. I want to know their weight, etc. And you will get that information as well. So for the time being, I just want to present how easy it is to build something up if you have like an existing data model. You can build on top of that. Now, just for the time saving, I'm just going to quickly show that we have like a mutation. So if I go, and I had already implemented one previously, so the only thing that would be modified is in our startup, beside adding a query type, we would add a mutation type. So that's represented by a mutation class. Going to our mutation class here, we would add the player. We can add define parameters and save the player, and then add the player to the players, and then save the changes, and then also return back the player if the client side wants to work with that. So I'm going to start this one just to very quickly show. So this previously implemented one running now. Let's take this endpoint and also modify this one. So right here, I'm going to ask for the players, but where the team ID is 1. So we're only looking for the Jace players. If I run this, then 1 second here. How does my query look like? We're looking for team ID. Oh, it's an integer. So as you can see, the query language is very similar to JSON, but so we got the players here, right? Looks like 1, 2, 3, 4, 5. And in the mutation here, I'm going to add Ken Giles, run the mutation, and if everything goes correctly, then we have Ken Giles added. That's pretty much it. I'm going to have the one I've already built. I'm going to share that later on. I'll send the link to Obi. I'll put it in a GitHub public repository, and feel free to fork it and work on it, download it, whatever you please. And that's pretty much it. I think GraphQL is cool. It will not replace REST API, but it has its place, and it's worth looking at. I think there are some scenarios where it's probably a better option than a REST API endpoint.
That's great, Mark. Thank you so much for an awesome presentation. You have, I believe there's a question from Raghavan, so you might want to actually answer, although I took the liberty, to answer whatever I could, but please feel free to answer his question. All right, so on that note, we have one last speaker, Roy. Roy, you take it away.
Okay, great. Thanks, everyone. All right, so let me just quickly share my screen here. Okay.
525 here.
Okay. All right. Can everyone see and hear me well? Yeah.
Yes.
Okay. Awesome. All right. So, Obi, how much time do I have?
Well, about 25 minutes or thereabouts. Is that okay? Is that good?
Sure. Yeah, whatever.
Yeah. I mean, the good thing is that we guys are all, home. So, if you have any commitments, any appointments, and you wish to leave, so, you're welcome to. Although I would prefer you guys, stay till the end.
Okay,
Thank
so
you.
I'll make it quick and snappy and get to the point. So if you guys don't know me, Roy Kim, I just ask you to check out my blog at roykim.ca, search me on my LinkedIn. I have a new YouTube channel, youtube.com/roykimyyz. Appreciate if you can check that out. Just watch some videos. It's a brand new channel, so just like to get some viewership on it. What I'll just go through in the next 25 minutes and some Q&A is to just give a real like live demo on what Kubernetes is in terms of hosting multiple applications, okay? And what's the key value proposition with Kubernetes. So I like to encourage you to ask questions, like go off mute and ask me questions and make it an interactive session. I don't mind. Also, let's see here. I'm trying to see if I can, how do I see the chat window in case I want to answer questions or something? But Obi, just interrupt me if there's a question in the chat. And I'm happy to answer. So, so really, so the present objective is to show you, how apps are hosted and how you manage them and how do they run together. Okay, so hopefully some of you kind of know what Azure Kubernetes is. So in a nutshell, it's a managed service. Okay, not completely serverless. There is still some. It's really like a managed IaaS, I would say, infrastructure as a service with VMs. And so it just hosts containerized application using the Kubernetes open source software that is basically an orchestration engine, okay, that helps deploy, schedule the containers inside the pods and all that kind of stuff. So I'll just show you how that is instead of talking. Okay, so by showing you, I have these applications, okay, that I've deployed. So they're just, good tutorial, simple applications. So one is a microservice. I'll show you a microservices in action using the Istio service mesh. So this book info app, I have a voting info app that's a MySQL database. So, and I kept unpacking on other applications over the last few weeks. So, so let me just start off. I'll show you this app right here. It's just a simple to-do list. It's going against, it's a .NET Core, and it's going against Azure SQL database, okay? And let's just add something in here. So create and voila, okay? So right here, and then another application, I'll just show them all. Wait a minute. Okay, so I have this voting app. Okay, dogs, cats. You can go to voting.arkin.ca. This is a simple Hello World app. It's extremely simple. It's the basic tutorial that you have. It doesn't do anything. It's just you just refresh. There's a guest book app. So you want to assign this guest book, to show that you've attended this meetup. And so that's in the same Kubernetes cluster. I even have a WordPress, okay, hosted, a full-blown WordPress with its databases inside the cluster, which is pretty cool. Go to this article, Hello World, and then a more sophisticated application. So this is WordPress, wordpress.arkin.ca. So a more sophisticated application I have is Istio, right? Which is microservices based. So the whole the UI here is like a one service. Book details is another service, okay, that is being called to populate this section or this data. Book reviews is another service, and the review service will call will come up with a bunch of stars. So there's three versions of this review service: one that doesn't have a star, one that has black stars, and one that has red stars. Okay, and then there's another service called rating. So the architecture behind it is the product page, which is the main page. The detail service is built in Ruby, and and then the review service is three versions, and it's just equally kind of weighted the traffic. Okay, kind of on purpose here. You know, it's just showing kind of example of A/B testing if needed, and then a rating service behind the scenes. So the really unique thing about Kubernetes and containers is that you have this application, and it's really has different programming platforms. Okay, it's not all like, you know, Java or all .NET Core. Okay, because it's very microservices oriented, and with the power of Kubernetes and containers, you can have this architecture, right? So that, you know, down the road, if you're going to have another service, and then there's a development team that goes, oh, we want to use Go or .NET Core, then you can just do that, right? And there's not much disruption or complexity in the application kind of as a whole. Okay, so how do we manage this stuff? What does it look like from a management dashboard? Okay, one view is, let's see here. Let me bring my VS Code up here. Okay, so one way is using Visual Studio Code Kubernetes extension. Okay, we have here our namespaces. Okay, and you know, we can let's see here. You know, kubectl is the command line interface to manage, right? So we can say get nodes, and then we have 4 nodes, which is really VMs, and then get pods. Okay, so those are the pods within the current namespace we're in. So that's kind of how that looks like. And then we can traverse, and we can see the 4 nodes right here. And within each node are all these pods. Okay, so I deployed a lot of applications, and you can see everything's green lit, and that's awesome. And so, so I drew this diagram right here. Okay, and so what I wanted to show here is really kind of how they're logically organized, right, in a cluster. Okay, so I have the book info application, so the guest book, hello world, and voting, okay, in this diagram. So these are the kind of like the light purple. So those are like the end user applications, right? And then in the light green are like applications that I've used that support the end user application. So like monitoring, you know, Prometheus and Grafana. Kiali is another kind of sort of like a monitoring, more of a graphical monitoring. And then we have Nginx that help exposes these applications to the outside of the cluster, right? So that, you know, an end client, like a browser, can have access in. You know, you need some kind of ingress controller or gateway, okay, to do that, right? And an ingress controller will support HTTPS, TLS, SSL, you know, any layer 7 kind of management, okay? Also, here I've used the Istio's ingress. So I have 2 here. You don't have to have 2, but it just shows the flexibility of leveraging different approaches and techniques. Okay, for monitoring, I don't have to do these 2. I'm sure there's some other open source, but these are the most popular ones. And then the kube namespace is what comes with, you know, a standard Kubernetes install. You know, that help, you know, manage everything, right? It's really the guts behind you know, Kubernetes. Okay, so again, in summary, I organize them in namespaces like in this way, so that you can group like an application, and you can give permissions to, let's say, a developer team to just only be concerned with a certain namespace, give the operations team kind of full admin, or give a security team like read access or something like that, right? And then, these kind of like, application supporting services, right? Or app infrastructure constructs, okay? Now, what about from a higher level, like where does Azure come into place, right? So within Kubernetes service, okay, you can leverage, a bunch of Azure services, okay? So as I mentioned, we're leveraging virtual machines, Azure virtual machines, right, to support the cluster. And we have an Azure load balancer, okay, that helps with the the inbound and outbound traffic, okay. We have Azure Container Registry, which is a repo of the container or the Docker images, okay, but you can use other ones like Docker Hub, we have Azure Active Directory to help support role-based access, okay. So you can, manage through your identities, okay. So let's see here, and then of course manage disk, okay, and Azure Monitor and Workspace for monitoring. So we can have managed to persist the data storage, okay, because for persistence, okay, because when these things scale out, or a pod dies or gets killed, the data will go with it, unless you bind it to a Azure managed disk, okay, which I've done in this demo. So that's that. Any questions so far?
I don't see anything yet.
Okay. So let's see. Let me show the Kubernetes dashboard, which helps manage your cluster and your applications. So let's see here. Where was the? So I'm just trying to find that browser window. Okay. Bear with me here. So, all right. So, okay. So right here we have the Kubernetes dashboard. This is also hosted within the cluster. Okay. Let me refresh. Okay. Oops. Let me get the token. The session expired. No worries. I have it here handy. So let's see here. So it's just a token. So this is one way of authenticating. So here we have Kubernetes dashboard. We see CPU usage and memory. So as I mentioned, the namespaces, how I've logically organized things. So the book info app, if we go here, we'll see the deployment objects of all the microservices. So as I mentioned, there's the product page, there's the reviews service, version 1, 2, 3, right? And then the pods that go with it. Okay. Let's see here. Let me try something out here. So one thing we can do is, so I had this load testing tool called Siege. So let's run that. Okay. And what we'll see is probably some activity kind of spike up. Let's see here. So spiking up a little bit. Okay. And we could even scale this out to 2 pods if we like. And let's see here, where's the pods? So right here, the product page. So some detailed information. So let me see, sorry, let me go back here, the product page. I'm expecting it to see 2 pods. So right now there's 1, but we can have the traffic load balanced. Okay, let's try that one more time. Okay, so yep. So another pod is being provisioned, and it's that fast, as you saw, right? That took like, a few seconds. Okay, and if I click into here, go into the replica set. So we have the 2 pods here, and it was created 18 seconds ago. So in terms of like scalability, or if you set it up to auto scale, it can do it pretty quickly. So that's one really good advantage of leveraging kind of Azure Kubernetes or Kubernetes in general. Okay. And the other thing I can show you is, let's see here. So we have here the nodes, right? So we have, well, 3 active nodes. I think this one is being created because I also have auto scale on the whole cluster, so that if since I did that load test, I think this is on its way of being provisioned. Okay, and this will take some time because you're actually setting up an actual VM node, right? And as you can see here, that the CPU request, it's around 94% to 83%. It's highly utilized. Okay, and so this 4th node is being, I believe it's being provisioned. Okay, and then you see the usage kind of going up. Okay, right there. And so hold on a sec. Let me just refresh this and show kind of the monitoring that happens. So if I go to, so like in the chat, like, is anybody working on Kubernetes or planning on it in Azure or anywhere like AWS or Google? Let's see here. And then if we go to insights on this, we can see some, kind of Azure native monitoring. Okay, let's have that load up. So we can see here the last 6 hours on the monitoring. Okay, let's put the last hour. So we here see node CPU utilization. So just a moment ago, I ran kind of a load test, and that was being, so there was some activity there. Okay, and then here we see the node count. So as this was spiking up, then auto scale on the cluster kicked in, so the node count went up. Like, I think from here, like before this time, I had some load tests set up, so it went up a node count, and then there wasn't much activity, so Azure scaled down the cluster, right? And then there was no activity for a while here, so that went down. And then since I have the load test on, after some time, it should another node should be introduced. Okay, and then we can drill into here. We see some further more detailed information on the monitoring, like telemetry, right? So here's the Kubernetes dashboard, the pod, and you can see that there's been some utilization there, etc. So that's that. Okay, let's see here. So let me show Kiali. Okay, right here. So that's being active. So right here, this is that that book info app, that microservices architect. So again, here's a product page, okay, and here's the details service, review service, version 1, 2, 3, and then the ratings, because V2 and V3 rely on the rating service to give like the number of stars, okay. So here we can see the response time by selecting on it here. We can see the requests percentage. So here, obviously, it's going to one node, so you see 100% traffic. And then from this product page, you know, the traffic is split up because some of it is going to the details page, some of it is going to reviews, and then from reviews service, right? It's, you know, equally weighted to hit like the either version 1, 2, or 3, right? As you've noticed. So going back to this, that's what it looks like. And if I go refresh, right? So you can notice the stars, you know, the 3 versions. Okay. So you're doing refresh. So you guys can check it out too here, bookinfo.arkin.ca/product page, if you want to play around with it. And let's see here. And then we can find out requests per second, right? So this one is 64 requests per second. This one, and then the traffic is kind of distributed, you know, 13 requests per second. And then from here, you know, 4.5 requests per second. Okay. And so, you know, this tool Kiali is a way of kind of visualizing your microservices application and seeing kind of the traffic flows and some performance metrics. Okay. So, and then, you know, so one good scenario to do is the Istio is that when you go into production and you have a new version, like we see here, like 1, 2, and 3, you know, you want, and you're a little bit being very cautious, you can enter your new version, let's say version 3, give it like 5% of traffic, okay, and then slowly kind of roll that in, okay, and then wean off version 2 and then increase version 3, you know, check your application logs and those things if there's any errors, or you know, look at its response times as you can see here, you know, to see that it's, you know, healthy from a performance perspective, and then kind of roll that into V3, right? So you have a very smooth transition, right? You know, in some cases, it doesn't hurt to have version 2 and 3 going at the same time, because it can just be you know, a minor change, right? You know, so like the color of something, you know, or yeah, things like that. So that's Istio, right? Yeah, Chris, I see your comment here. Yep, some cool tools here. Another cool tool that's open source I will use is Grafana. So again, this is more detailed monitoring. So here is to analyze your service mesh, response size, incoming success request. We can see some, let's see here, cluster level monitoring. Again, CPU usage, pod CPU usage, memory, network IO. So it can get really detailed. Let's see here. Are there things I can show? Another dashboard. So here, all the pods, you know, and you can go by, you know, specific node, right? Oh, look here, we got like 5 nodes now. That's pretty cool. Okay. So I've done custom dashboards where you get down to the specific like application, okay, and you see its CPU and memory utilization, you know, latency, response time, right down to that level of detail, right? So really the key takeaway, so I'll make some final statements here. The key takeaway here is really in your architecture here is that you have a lot of density of your hosting your applications, right? So like I remember having projects where in a very large organization, they just a lot of times they just need a simple web application with some SQL database, okay? And it would just take many weeks or months to get that set up, from the IT team or operations and things like that, right? To have a dev, test, and prod environment, or to just have initial dev environment, they need to get another VM, of some sorts, right? But if you're just want to start out with a dev environment, you can have an existing cluster, okay? Reserve very little CPU and memory utilization, okay? Which is like, 10% of a virtual core. Because honestly, some of these applications, right? Some of these pods, I give it like 10% of a virtual core, okay? And it's fine just for like development, okay? And then but you give it more obviously when you're enacting some more load, or you have auto scale, like pod auto scaling. You have meaning from one replica to 2 or 3 to take on more load, right? So you really have very more optimal resource utilization with that. Okay. And as you notice, I have like those 6 applications I hosted, and it's going across 3, 8 gigabyte, 2 virtual core nodes. Okay. And it's 3 nodes. Okay. And as I'm using more, as I'm testing and I'm using more, like it'll introduce another node. Okay. So that's the key thing or value proposition that you would get from an infrastructure and cost point of view, is that really high density, okay? And you don't get empty space or empty usage that you would have with like a brand new VM, okay? And it's sitting idle and at 10% CPU usage all the time, okay? So that's kind of what I want to bring home, that kind of message. But I'll open it up for any questions, comments.
Hey Roy, what's your YouTube channel name?
It is roykim.com/ no, sorry, it's youtube.com/roykimyyz. So yeah, actually I should share some resources here. So okay, right here. So YouTube. So I'm working on a new video. Hopefully I'll publish it in a week. Roy Kim YYZ, which is the same as my Twitter handle. So I launched it like maybe 4 or 5 weeks ago. So I have this presentation right here. This one's on persistent storage. This one right here on the left. So yeah, 321 subscribers so far. Yeah, so please subscribe. Like to get some activity going. Put some more out. And also from my GitHub. So some of these scripts that I have, I update and publish them. So you go to github.com again /RoyKimYYZ, right? And you will see Linux scripts. So just any Linux oriented, managing Azure, Helm, Kubernetes. So I have a lot of scripts in here, how to deploy that WordPress. I compiled it together, installing WordPress. So yeah, please check it out. All of my resources. Yeah. So are you guys excited to hop on and and really get your hands dirty with Kubernetes and Azure?
Hey Roy, it's Ashwin here. I
Yeah.
was wondering, I have never actually used Docker or Kubernetes. So how much of a learning curve is there for that?
Yeah, it's a big learning curve. I'm serious. But after you get over the learning curve, and I'm still learning, well, yeah, you're always learning with any technology, but yeah, just one step at a time. I just start off with AKS tutorial, like from the Microsoft Docs. Let's see here, deploy. I just started with this tutorial right here. And then you just keep on building on top of it, and then you start to ask questions. Oh, can I do this? Can I try that? Right. So my first little tutorial is really this simple application, which doesn't do anything really. It's just a one container app. There's no database. It's a hello world, right? So, but yeah, it's a big investment. But yeah, it's I think it's growing in demand. A lot of people don't know how to do Kubernetes well, but because of these reasons, like you can host in Linux, you can host in Windows, you can use .NET Core, Node.js. You have so much flexibility. Okay, it's such an open platform, strong ecosystem, and also like efficient. So like IT management I think would love to hear that is efficient management, right, of their resources, right, compute resources, right, and the ability to have strong DevOps, right, because everything can be automated, right, because of the kubectl command line, like, some other automation tool like Helm for package management, like in deployment. So all those things, right? Again, like I did all that, like that demo you saw, right, was done using automation scripts mostly, right? And I published quite a few of them into this. So if I were to rebuild this demo, um yeah, I can do it in several hours, to be honest. Like, it was a lot, right? But several hours with some issues and bumps, even though I have a lot of scripts, but it'll take me like 3 to 7 hours, something like that. But that's the power of you know of like Azure Kubernetes. So does that answer your question, Ashwin?
Partly, because the tutorial it starts with Kubernetes, so I don't necessarily have to start with Docker.
Oh, no. So you start with Docker, okay? Okay, step one is start with .NET Core or your programming language of choice. Containerize it with Docker, okay? And then once you containerize it, you have to publish it to a Docker repository, like Azure Container Registry, okay? And then you deploy to Kubernetes using the Kubernetes YAML files, right? So, and it looks like uh, let's see here. What's an example? So basically, it looks like this, like a YAML file for Kubernetes manifests, right? And um, and there's a hold on image. Yeah. So anyways, like these things will pull the image. Like there's a line here, there will be a line here that says image, and you give it the URL to your Docker image, and then it will deploy it into your Kubernetes, and then from there use Kubernetes Kubernetes dashboard.
Okay, thank you.
Yeah, but yeah, it's a big. Those are big steps that I mentioned. Okay, but I just try it out one step at a time, but it is a lot of steps, So, but if you got it down, you're golden. You know what I mean?
Yeah, I understand.
Yeah. Okay. How about you, Chris? Any questions or?
No, it's nice to see all these tools. I haven't got to use them all.
Yeah.
I've used it in Azure a bit. Does anybody do this on-prem, by the way? Kubernetes?
Yeah. I know some people who do POC labs on VM infrastructure on-prem, right? Sometimes it's cheaper to do it, but you don't get the scalability. So I know some people who do it just for POCs. They just install it on a VM, right, and then off they go. Yeah, because actually AKS, it's pretty expensive to run. So for me, my demos, I have to turn them off, really, right? So I have to diligently turn them off.
You're running a bunch of servers, obviously, yeah.
Yeah, and then the disks and everything. So what I do here, and it's not recommended for production, but for dev, what I do here is this one right here is running. So I just deallocate this VM scale set. So okay, cool. So let's wrap up. Obi, any questions, comments?
No, this is great, man. This is awesome. I just I was curious. What are some of the deployment options you have when using Kubernetes?
So you can use the main thing is a DevOps pipeline. Okay.
CI/CD.
So Kubernetes. So let me Kubernetes DevOps pipe. Yeah, CI/CD pipeline. And again, it's pretty complicated at first, really. So there's many variations, right? Let's see here. What's a good one? So here you get your repos, you build it, right? And then you build and you containerize into a Docker image. You push it into ACR right here, Oh, sorry, where did it go? Yeah, you put into ACR. And then you have a release pipeline so that your Kubernetes YAML files, and then Kubernetes will pull the Docker image, right? Once it's instructed to do so. That's the high level.
Sure, I think that's good.
Yeah. So, but if you guys like to have me back again, I like to do a more focused session on perhaps like auto scale and a bit more zoom in into monitoring. So auto scaling, kind of horizontal pod auto scaling and cluster auto scaling.
So what do you say, Chris? Do you want another detailed demo in the middle of summer while having a barbecue?
Well, you're gonna have to watch me eat it as well. But I would love that.
Yeah. Well, you know what? I think this